it's Chris Norman. I'm back again with another video. This time we're here with Christy McLemore from CreaForm, and she's going to be scanning the fuselage for us using the CreaForm, which model?
First, and then we'll do the HandySCAN if we need to, but we'll start with the Go Scan.
Okay. So as ever, did a video about my experience scanning with the Artec Leo, and it worked pretty well for some straight line parts, but I had a really difficult time trying to line up more complicated parts. So the fuselage was critical to scan the inside and outside and to make the alignment work, the interior of the fuselage. Since I'm doing some serious modifications to the firewall, creating a tilt-up instrument panel with the canopy, it's imperative that I work from the CAD model in order to make that happen. So I'll let Christy introduce the scanner whenever she's all set up.
Okay, so we're going to scan this plane with the HandySCAN Black Elite. We tried it with the Go Scan Spark a little bit ago, but I think there's something going on with it. I'm not quite sure what the problem is, so we're going to switch over to the HandySCAN and take a look at that and how this one performs a little bit differently. So first thing I'm going to do is change in the product manager to my active product and make it my HandySCAN. Have a new session. So this one's laser. It's only going to track itself and position itself with the target stickers. So we're going to add a few more than what we had with the Go Scan. And I will get it calibrated first, and then we'll go add some targets and get going. So calibration process is very similar to the Go Scan. I'll scan the barcode, and then we're just going to be measuring these targets, different heights and different angles.
I can see the blue light better in my camera. Pretty cool.
Yep.
So the barcode lets you say, hey, this is this calibration plate for this scanner.
Correct, yeah. So this says use with scanner, and it has the serial number for that
so
scanner.
If you tried to use one that wasn't for this one, it would say, sorry, no.
Yeah, it would just launch this for the scanner that it's calibrated to. So it would be measuring, you wouldn't really be getting a true calibration because it's not registered to this.
Okay.
Okay. All right, so Chris and I went ahead and tag teamed and added some more targets so that we can scan this with the HandySCAN now. So we didn't add extra targets down on this end. We're going to focus in here. So we spent, about 20 minutes putting these targets on. So there's a lot more, and that's because with the HandySCAN, we are only positioning the scanner using these targets. So that's going to maintain a really high accuracy, but it's also going to give us that flexibility and portability that we want.
It's the only Lancair I've ever seen with measles.
Yes, measles. I keep saying I need to make earrings with those targets, and I haven't done it yet. So one thing I want to do, I'm going to do the same thing with the configuration with the shutter speed and say auto adjust. And I'm going to point it down. And this one is a lot easier to adjust on the fly too. And I'm just going to point it until it tells me that it's optimized. I'll say auto adjust first. And then you'll see that shutter going up and down on the...
Does the blue light just mean it's scanning?
And so it's...
Oh, it turned green.
Yeah, it's good. So so this, whenever I said auto adjust, and you press the scanner button, you hold it over the area that you want to scan, and then you'll see the shutter going up and down, and it's just adjusting to what's right in front of the scanner. And then that's how you know you're optimized. So now we are ready to scan. I'm going to keep all these settings the same, but before I do anything, I'm going to change the method this time. And I'm going to say, let's scan just the targets first. And so I'm going to try to build our coordinate system before I grab
geometry.
A lot of the geometry. Yeah.
Just to see if it...
Well, what I want to do is I want to utilize what we call the spiderweb method. So when you have something big, it's best to start in the middle and work your way out like a spiderweb. So because this is the area that we're focusing on, and I'm going to start in the middle and come this way, and then I'm going to come back and work along the side, then come back, and I'm just going to make these paths and build my coordinate system first, and then that will get us kind of set for when we're ready to start scanning. I think it'll be an interesting workflow.
So it builds the geometries for just the target locations for reference,
right?
And then you can go back and fill it in with the cloud data.
So we're not going to be capturing surface. We're only going to be capturing the target. So I'm going to press and hold. And then we're going to can't see the screen, sorry. Let's hold it this way so it doesn't glare on me. All right. So it is picking up.
So it is just pulling targets. You're building a solar system.
Right.
Yeah, it's really tricky on curved surfaces to stay at the right
At the
length,
right, range.
distance. Yep.
Yeah. It's really hard to see with the glare. Let me see what we got.
Yeah. Do they have? And then you change the color of the targets. What did the pink mean?
It looks like that might have been where we just grabbed. So let's keep going.
Yeah, I see it. It lights up the ones that are blue that it's already captured.
Okay. Get in there and get a little bit closer. Okay.
It's like Star Trek level stuff.
Yeah. All right. Well, we're about to find out if this thing can see through your. This will be interesting.
Okay, so we've had one spot where we've had some problems, and we're thinking maybe it's the translucency of the fiberglass, but we're about to find out. Of course, we pulled the gate, the door closed, and we're going to find out if that corrected it too.
How's it looking up there?
You're flipped around to where I can't. I don't see anything now.
Okay, so maybe we.
Maybe literally changing the lighting.
Yeah, help to the translucency of the part.
Yep. It was just too much light, letting the outside targets be seen through to the other side.
Yeah.
Okay.
Interesting.
So, okay, all you guys out there that like build airplanes or Corvettes.
Oh yeah.
You need to. So most new stuff is all carbon fiber, so it's black. You can't see through it.
Right.
But it's actually hard to scan carbon
Black
fiber.
is hard to scan, but not with this. Yeah.
So in actuality, it only took us about maybe 20 minutes to put targets all over the plane, but then the scanning itself actually goes really quick. There's only been one hiccup, and we thought it was a cable, but it turns out that it might have just been, I pulled the door closed. We think maybe because the fuselage is translucent, that it was picking up targets or something through the window on the side of the Lancair, and that may have caused this erroneous pattern that you'll see in the video. So as you can see from the scan data, the quality is remarkable. You can even see the honeycomb pattern inside of the Nomex honeycomb core material. And this allowed us to do some incredibly precise work. And you can see the surfacing that I'm beginning to build in patches, which basically converts the mesh data into a surface that can be used inside of Solidworks to construct an actual file. And it doesn't do it fully automatically, but it is remarkable how simple it is to do it inside of VX Studio, which is a software program that is provided by CreaForm. And essentially, I spent several months fighting with the version of the software for doing this with the Artec Leo scanner before someone finally said, hey, you should check out the CreaForm product. And I have to say that the surface generating tools and the entire scan process was just a tier above the quality of anything that I captured with the Artec Leo product. Admittedly, I also wanted to do this for posterity to create a accurate surface model of Lancair 360s. There are quite a number of these kits out there, but that doesn't necessarily mean that Lancair or anyone has every part that exists for the plane. So I kind of thought, well, you know, not only can I create this, but I can make this data available so that people can recreate a part or something if they have problems. But as you can see, I'm going through the workflow, and essentially what I have to do at every point is to create kind of patches within the software to minimize the total number of surface steps. There is an automated tool that will create a huge number of tiny little square patches all over the model, and it's just too much. And because I chose not to use that and do this by hand, we ended up with, I think, a better product. It's not perfect, and if I did it again, I'd probably do some things a little bit different. But in the end, the entire model is plus or minus just a few foul everywhere on the model. There will be a follow-up video, a part 2, if you will, of the scanning process, and I'll dive more into some of the nuances of the workflow and also show the differences that I uncovered working with both the Arctech Leo product and the CreaForm HandySCAN Elite Black scanner. So now we have the big reveal. After several months of work, this is the result. This is a surface model that has been imported into Solidworks and turned into a solid. And I've imported my seats, the UL 520T engine, and a couple of Dynon primary flight displays just to kind of show it off. But this model is accurate to plus or minus just a few thousandths of an inch and includes all of the geometry and features of the entire fuselage. Now, the top cap is also a separate model that I scanned and created. And here's a few progression photos showing some of the other parts that were scanned, as well as the kind of final result put together. And then this is actually one of the focuses of why I did all the scanning. You can see that the model allows me to extrude parts until they terminate with the surface. So this means you can actually build off of the surface of this model for any kind of accessories or parts that you want to build inside of this plane for modification purposes. And here's a nice shot of the instrument panel that I'm currently working on, and a few of the other parts that we happen to scan, like the belly pan, the main spar, and the wing spars, as well as the unfinished wings from one of my kits. I feel like we've covered a lot of territory in this video, but we really have only skimmed the surface of the scanning process and the workflow, and I'm excited to create a follow-up video to deep dive into the scanning process, talk about the workflow, and highlight how you can do a lot of this work in the SolidWorks Maker Edition that's available through the EAA, and then follow up with subsequent videos covering a lot of topics related to the modifications that I've actually already finished for the plane. And yeah, then just follow up with a series of videos deep diving into the building. So now that the weather in Houston is actually cooling off, I'm looking forward to actually getting into the hangar this fall and starting to do a build and CNC cutting the parts that I've designed, which I haven't really shown all the finished parts of, but I actually have finished a lot of the parts for like the tilt instrument panel and the firewall forward. I'm working on the engine mount, but I've got all of the ribs and everything CNC cut, and going to start showing that stuff off as well. And I plan to document the build process fairly well, because quite frankly, the manuals from the original 360 are just kind of difficult to follow. But between the 3D models that I've created and the videos that I'm going to produce, I think you'll be able to easily follow along. So that concludes this video, and I'll just leave you with some fun stuff to watch.